Hi everyone. Sorry I can't be there today. I am working with Dr. Patrick and other teachers on figuring out how to do the concurrent education that we will be doing come January. So instead, you guys get to watch me on a video, and I am going to walk you through the materials matter section that we're going to start. So we're moving on to Unit 2. We just finished Unit 1, and now we're going to move into properties of matter, starting with physical properties, okay? So, what is matter? Matter is any physical substance that has mass and volume. We've talked about these a little bit. Mass is specifically the amount of matter in a substance. So, how many atoms, how much stuff is packed into that space, okay? And then volume is the amount of space that a substance occupies. So, these can be very different things. Something can have a huge volume, but just a tiny mass. For instance, take a balloon. If you blow it up, it's going to take up a whole lot of space, but it's not going to be very massive. It's not very heavy because the stuff that makes that balloon up and the air inside it up doesn't have a whole lot of mass. It's not very heavy. There's not very much stuff in there. As opposed to if you filled a water balloon, it might have the same amount of volume as a regular air balloon, but because of the substance you put in that balloon, it's now going to have more mass, okay? Because the water is heavier, it's more massive than just the air was. So all matter has two types of properties. There's physical and chemical properties. We are only going to focus on the physical properties right now. We're not going to talk about the chemical properties till later, so don't even worry about that. So what are physical properties? Physical properties are characteristics that can be observed without changing the identity of the substance we are studying. So the reason I say that and I put that in bold and italics is because chemical properties are characteristics that do change the identity of a substance. So we are specifically talking about the things that you can observe with your senses that don't change an object. For instance, if I heat up a piece of metal, it's still going to be a piece of metal even when it's hot. If I boil water, it's still going to be water even though I've boiled it. If I paint my face for a football game, my face is still my face. The skin is still my skin. The paint is still the paint. I just kind of slapped it on there, okay? So physical properties are things that do not change the identity of a substance. So let's look at some specific examples. An object's state of matter is a physical property. So knowing whether it is a solid or a liquid or a gas or even plasma, all of those are physical properties. So for instance, when I talked about the boiling water, if I freeze water into an ice cube, it's still water, it's still H2O. If I let it melt into liquid water, it's still H2O. If I boil it until it evaporates, it's still H2O. Changing the temperature didn't change anything about the chemical makeup of that water. It's always still going to be H2O, okay? So again, state of matter, solid, liquid, or gas is a physical property. Shape is also a physical property. So I can take a piece of paper and cut it into a triangle or a circle or a heart or a star, and it's still going to be a piece of paper, okay? So the shape is another physical property. Density, we're going to hit way harder next week. So if you liked the math in the first quarter, we're going to do a little bit more math with density next week. But density is the measure of the amount of mass in a given amount of volume. So basically, let's differentiate between mass and density. So mass is how much stuff is in something. Density is how tightly packed that stuff is. So for instance, here's two cubes down here. One of them has particles in it, okay, and it makes the shape of a cube, but these particles aren't very tightly packed, okay? This cube, however, has all of its particles very neatly and very tightly packed into that cube. It's kind of like, let's talk about COVID, okay? It's kind of like COVID. before COVID, you could cram as many people into an area as people could stand, and no big deal, okay? So you could pack an area very tightly, so it would be a very dense area. But now with COVID, we need to socially distance and keep our distance from each other. So now we've spread out from each other wherever we go. So places where people are now less dense. So density is how how tight things are squished together in an area. Solubility is the ability of a substance to dissolve into another substance. So like these Skittles, this is a fun experiment. You just put some water in there and the Skittle casing will dissolve in that water, okay, which is what's making those colors come out of the Skittles. So whenever we mix if you've ever mixed lemonade, like Country Time lemonade or those Kool-Aid packets where you take the powder, you pour it into the water, you stir it up, you're dissolving that powder into the water, okay? So that is solubility. And solubility is pretty interesting. The reason it's a physical property is because you can undo solubility. So for instance, if you make lemonade, if we dump the Country Time powder and the sugar into the pitcher and then we add the water, stir it all up, we can drink it and it's going to taste like lemonade and it's going to taste wonderful on a hot summer day. However, if you leave that sitting in your fridge, if you leave that pitcher sitting in your fridge for too long, like weeks and weeks and weeks, you just forgot about it in the back of the fridge, you're going to notice that all of the solid particles, the lemonade powder and the sugar, it's all going to separate and settle into the bottom, and that water will be on top. So even though it seems like you made a totally new substance whenever you added the lemonade powder, you actually haven't. You've just kind of more uniformly mixed it all together so that it tastes better, but you can still separate out the water from the sugar from the lemonade, okay? So again, solubility is the ability of a substance to dissolve into something else. Odor. This one's plain and simple. If it's stinky, if there's a smell, if it smells good, however it smells, the presence of an odor is a physical property. Melting point is the temperature at which something changes from a solid to a liquid. So if you take an ice cube, put it in your cup, and you let the cup sit there for a while, eventually that ice is going to melt. And the temperature at which it does that is called the melting point. Boiling point is the exact opposite side of that spectrum. This is the temperature where a substance boils. So where you're going to get your water to boil, 212 degrees Fahrenheit, okay? So that's where the liquid goes from a liquid state into a gaseous state. It starts to boil and bubble and turn into a gas. Malleability is a fun one. This one is usually always reserved for metals, okay? So malleability is the ability to flatten a metal into sheets. So if you take a piece of gold and you take a hammer and you pound it out, you can pound out that gold into a sheet. So that's why if you've ever been jewelry shopping with your mom, they might talk about 14 karat gold, 24 karat gold. That all depends on how soft it is and how malleable it is, okay? Ductility, again, has to do with metals, and this is when you can take a metal and you can stretch it out into wires. So you'll notice in this picture all of these fine little pieces. Those are wires. So they took like copper and they were able to stretch it out and draw it out into nice thin strands to make a wire. Viscosity, this is honey here. If you've ever worked with honey, you know that it is thick, sticky stuff, okay? And that means it has a high viscosity. So viscosity is the state of being a thick, sticky semi-fluid, okay? So there's a lot of friction in those particles that make up the honey, which causes it to stick to itself, but that stops it from flowing, but it still can flow. It's just like a really thick liquid. Mass, we already talked about mass. Mass is how much matter is in an object, and on Earth we weigh it with a scale. Remember that gravity pulls down on mass. Okay, so anything that has mass, gravity tries to pull you down. And on Earth, we can measure that with our scales, with our weight. Magnetism is a fun one. So this is metals being attracted to other metals based on their electric alignment, their electron alignment. Color. So eyeballs are still eyeballs, whether you have brown eyes, blue eyes, green eyes, a mix of all three, whatever, okay? Color, we can change. Now, color can be a little bit different. Like if I paint the wall of my house, I can flick off that paint still. So that paint is just a mask. The wall is still the wall. The paint is still the paint. But I can put the paint on the wall and that will change the color of it. It's still a physical property. If I put on really blue eyeshadow, I can wash it off at the end of the night. It just masks my real face color. But if I dye my hair, let's say I want to be a blonde, okay? I'm going to have to bleach my hair. That is actually a chemical process. So whenever we talk about color, you have to think specifically about how you got that color and if you can get rid of that color. So if I color on a piece of paper, it's not changing what the paper is. It's still paper. And technically over time, that color can separate out, okay? So you got to think really carefully about color when using it as a physical property. Just remember that we're not talking about a color change. We're talking about the color right at that second. So my shirt is pink. We're not talking about that color changing. We're just talking about what it is at that second. Luster is a physical property that we usually reserve for minerals, which you actually are going to work with some virtual minerals on Thursday and Friday. Next week. But luster can also be applied to other materials. So luster is how a surface reflects light. And you break it down into three main types of luster. You have metallic luster, submetallic luster, and non-metallic luster. So we all know what metals are, and the other things that aren't metal are non-metals, okay? Plain and simple. So typically, whenever you guys look at metals, you think about shiny stuff. It's bright and it's reflective. So like on my pencil right here, the little thing that unites the pencil with the eraser, this is metal. And you guys know when you look at metal that it's nice and shiny, okay? For your submetallic, this is where it still looks like metal, but it's dull, okay? It's not shiny, but you can tell from the grayish that it has a little bit of reflectivity, that is still probably a metal, but it's submetallic. It's not the bright, shiny, polished metal. And then a non-metallic luster can be broken down into a couple different ways. It can be glassy. It can look like glass. It can look oily. It can look fibrous, like it has fibers in it. It can look pearly, like a pearl, creamy. It can look dull or rough or plasticky. So these are all your different examples of lusters. Flexibility, this one, basically you just ask the question, when you bend it, does it break? If you bend it and it breaks and makes like kind of crummy type things, then it's brittle. If you take like a metal and you bend it like this guy over here and it can just bend, then it's flexible. And thermal conductivity, this is the ability of an object to heat up or quickly slow down. No, that doesn't make any sense. Let's try that again. Thermal conductivity is the ability of an object to heat up quickly or slowly. Okay, so if you think about your kitchen, think about your stove. I'm sure you've noticed before that if you turn the burner on, over time, it's going to turn red because that means it's getting super hot. And if you touch that, ouch, it's not going to be pleasant, okay? So metal has a high thermal conductivity. It reacts very quickly and soaks in all the heat and retains that heat. But if you think about your shirt, you wear these t-shirts out in the summer in the bright sun, okay? And even though you get hot and sweaty still, when you touch your shirt, it doesn't burn you. You're not like, ow, I can't touch my shirt, okay? Same thing with plastics. If you take plastic and set it down outside, unless it's black plastic, it's probably not going to feel very hot to the touch. But if I leave water in the sunlight, it's going to get super hot. So again, thermal conductivity is how well a substance retains its heat, okay? So this is going to be super important on an assignment that you're about to do. So I'll explain that in a minute, but come back to this slide if you need a review on what thermal conductivity is when you see it on your homework. So whenever we're talking about physical properties of matter, you have two different kinds. You have characteristic and you have non-characteristic properties. This is a way to break your properties down into two different categories, okay? So characteristic properties are properties that do not depend on the size and shape, on the size of the sample. So characteristic properties can be used to identify unknown substances. They include density, boiling point, and solubility. So this means that it doesn't matter how much of a sample of water you have. One teeny drop of water is going to boil at 212 degrees, just like a whole big pot of water is going to boil at 212 degrees, okay? So if I have an unknown liquid, I can boil it and see at which point it boils, and then that temperature tells me what liquid it is, okay? Because it's very characteristic of water. It's a property that is just very unique to water. Non-characteristic properties are physical or chemical properties that are not unique to one particular substance. So like the temperature, the mass, the shape, and the volume. We can have a pencil that's the mass of 5 kilograms or 2 kilograms or 1 kilogram or 0.5 kilograms, and it's still a pencil. So looking at the mass of an object isn't going to tell us exactly what the object is, but it's still a property that might help us narrow it down, okay? The volume, if you just blow up a balloon a little bit, it's going to have a different volume than a balloon blown up really huge, but it's still going to be a balloon. So the volume doesn't really tell us specifically what an object is, but it can help guide us to the right direction. So characteristic properties are properties that stay the same no matter how much of that substance you have. And non-characteristic properties are properties that can change within an object based on size or based on mass or what you do to it. So why is it important to learn about physical properties? I'm sure you guys, this is something that should be innate to you. When you walk around the world and touch and experience things, you're observing their physical properties. Like, I still do this as an adult, but as a kid, I'd walk around and I'd touch all the clothes whenever I'd go shopping with my mom because I loved to see what they felt like. So I was observing the physical properties. Is the texture rough? Is the texture soft? Okay? The importance of applying this in the scientific setting is because in science, when you are inventing new things and creating new things, you have to take into consideration a substance's properties. So for example, jets are super high-powered vehicles that need materials that can withstand weird pressure, weird temperature. It's got to be really, really strong. So we know the physical properties of titanium can withstand that pressure and that temperature change, and it doesn't rust. So it's going to be very strong in a jet to make the plane faster. Titanium is also non-allergenic. So because people aren't allergic to it, and because it's rust proof, not only is titanium good in jet engines, but it's fantastic to make artificial joints. Like if you've ever heard of a grandparent or a parent needing a knee replacement or a hip replacement, they might have used titanium because it's safe in a human's body. Or piercings, some people get piercings all over the place, all over their body. Titanium is a safe metal because it won't rust and it won't react negatively with your body. So it's important to know the different physical properties of different metals so you know which one will work best in different situations. Okay, so your next step here. If you got a packet at school, so if you and your parent came and you picked up a textbook and you picked up a packet, you're going to flip to page 3 of that packet. If you did not get a packet, you need to go into Google Classroom and find 2.2 Materials Matter under the November 9th through 13th module in our classwork section, okay? So again, flip to page 3 of your packet or go to Google Classroom and find the assignment for today called 2.2 Materials Matter, and you're going to follow the directions to complete that assignment. Let's see if I can pull it up real quick. Okay, so here is what your assignment looks like. So on your packet, or if you pull it up in Google Classroom, this is what your assignment is going to look like. You are going to grab these materials, and I'll give you some examples of them in a minute, and you are going to fill out this chart that describes the physical properties of your object. So for instance, if we look at fabric, the color, if I were to look at my t-shirt, I would say the color is pink, the texture is soft, the luster, it's not very shiny, so I would call it dull. Okay, that's going to be my luster. Flexibility, I can bend it and it's not breaking into a million pieces, thank goodness, because that would be embarrassing. Is it malleable? Since we said that malleability is mostly a property of metals, I wouldn't say my shirt is malleable because it just kind of falls out of shape. So I can't shape my shirt and then it stays there forever, okay? So it's not malleable, it's not a metal. I can't bend it and leave it that way. Thermal conductivity, I'm going to say it has a low conductivity because I can wear this in the sun and it won't burn me, okay? So it's got a low thermal conductivity. Whereas if I looked at the metal, let's say I'm looking at the metal on my pencil here that I was talking about earlier, the color is silver, so I'd say silver. The texture is smooth, it's very smooth in most places. The luster is shiny, you can tell as I move it around, it's very shiny. Is it flexible? I know from past experience as a kid bored in class that I can bend this, okay? So I know that this metal is flexible. I know that if I take it and crush it in my hands, it's not gonna fall apart into a bunch of tiny pieces. Is it malleable? Because it's metal and because I can bend it, yes, it's malleable. Thermal conductivity. If I set this in the sunlight for a really super long time or I heat it up somehow, it's going to get super hot. So it has a high thermal conductivity because it's going to retain that heat. Okay, so that's what you're going to do. You're going to walk through these different examples that you have. You're going to observe them and you're going to fill in this chart for me. If you need to, if you can't figure out thermal conductivity, malleability, or flexibility, you can go to the internet, you can Google it, that's fine if you want to. But what I want you to be careful about is do not break anything you've been given, okay? Use your background knowledge. For instance, if your mom hands you a glass plate to use for this experiment, don't throw it against the wall and break it. Your mom did not sign up for that, okay? But you know from past experience that if you accidentally drop that plate, it's going to shatter, okay? So it's going to be brittle. Same way with ceramic. If she gives you a coffee mug, don't throw it down and see what happens. Use your past experience to tell you, if I drop this, it's going to break into a bunch of tiny pieces, okay? And then if you scroll down, it may say interactive media down here. It may not. But if it says that, don't worry about it. All you are doing for your assignment is working on this table, table 1, okay? And then finally, here's some of the materials that you can use for this experiment. For glass, you can find a drinking glass. You can look at your window pane. Plastic items can include plastic spoons, cups, dishes. You might have some plastic ones. A lot of toys, paper, obviously paper, metal, your forks and knives and spoons, a doorknob, the hinges on your door. There's lots of metal around you. You just have to look. Stone, you can use if you have a granite countertop, or maybe you have a stone paperweight, or you can go outside and you can find a rock, and the rock counts as stone too. Or if you're like me, you might have a whole box full of rocks. I do. I have 2 of them, very big ones. You can use those too. Ceramic could be something like a mug, it could be a cup, it could be a dish. Fabric, we all know what fabric is. You're wearing it, okay? You're wearing your fabric right now. Wood could be your furniture, maybe if you're working on a desk. or you have a dining room table, or you have a chair somewhere, there's going to be wood in there. Your floor might be wood. Outside, I'm sure there's a tree somewhere nearby. There's wood right there. Cement or concrete, you've got a sidewalk. You've got, maybe your porch steps, cement or concrete, okay? So that is your assignment. If you have questions, email me and I will get back to you as soon as you can. Feel free to text your friends if you want to work with them on this. That's fine too. But I'll be around if at the very latest this evening, and I'll write you back, okay? So I hope you guys have a fantastic day. Good luck on this assignment, and I will see you soon.